like the fact that 5 and 1/5 are reciprocals, or 4/5 and 5/4 are reciprocals, because both of them have a product equaling 1. Whole numbers can be tricky for people. Just put a 1 under it and then flip it, and you now have its reciprocal. Fractions are easy. 1 is its own reciprocal. It's just not like the normal thing. And 0 has no reciprocal. So when I was talking about this, I was saying I wanted you guys to think about these kind of things, okay? But 1 is its own reciprocal. It's the only number that can multiply by itself and equal 1. All right? In the land of gray box definitions, in algebra, they say any number multiplied by the inversion of itself is its own reciprocal, okay? So this flipped, okay? That's the sort of the algebraic definition of reciprocals. The properties that govern negative numbers, you keep the sign. So like the reciprocal of -2 is -1/2, because remember the goal is when those are multiplied, you get a positive 1. Okay, so if a number is negative, its reciprocal is negative. If a number is positive, its reciprocal is positive. All right, let's go into example 1. And some of these examples don't seem to apply to this lesson, but just work with me here on this. The reciprocal of -1 is -1/4, right? That's the reciprocal of -4. The reciprocal of 5 is the reciprocal of 5 is 1/5, okay? The product of these two reciprocals of these is the reciprocal of that. Close the door for me, would you, Allie? If I take these numbers and multiply them, the product of their reciprocals looks hauntingly familiar. I know, right? I wonder why. When you are messing with reciprocals and variables, I'm going to flip to the next page. Ben came up with a really good question, and I'm going to kind of lead with that. I don't remember exactly what it was, but it was like 2x times 3 times 4y. This isn't really related to reciprocals, but it'll get me there. This means 2 times x times 3 times 4 times y. And the result is the product of the numbers times the product of the variables, which would be what, 24xy? Okay, the reason I'm leading you into that is as we, actually this technically is not example 2. This is still part of example 1. Sorry about that. Because what I have for you is if I have a number and a letter multiplied by what appears to be the reciprocal of the coefficient of that variable, we can rearrange the numbers just like we did up here to look something like this. Your answer is going to be 1m for this case.
So we basically like cross cancel.
Yeah, exactly. Exactly right. A more difficult representation of that is going to be the next one I'm going to share with you. I'm going to call it letter C. Negative 64 times A times B times negative 1/8. What Jada already identified is you don't even have to maneuver the stuff around. When you are multiplying in order, all you got to do is look for opportunities to cross cancel. So I would simply make that a 1, make that negative 64 a negative 8, and now the end is going to be 8AB. Negative 8 times A times B times negative 1, positive 8AB. Or longer versions. Example 2. If you are distributing a fraction into a parentheses looking like this, what Jada said holds true for this as well. You can throw ones under all this stuff. And this cancels, making this into a -4. This and this becomes a 1.
Justice.
Your end result is 4x plus y. Good luck, kill it. 4x plus y. Okay? This cross-canceled with this, leaving me a 4. This cross-canceled with this, leaving me a 6. A negative times a negative is a positive. And there's your y. Positive. Got something weird in here. Okay. I'm sorry, that should be a negative y as I'm looking at it. Jeepers creepers. Got all distracted. Good luck, soccer team. Negative times a negative is a positive. Negative times positive is a negative. Now that's a subtraction sign if I ever did see one myself. Let's do one more like that since I train wrecked that one. 7 times 21g minus 14. Throw our ones in it. Here, this is going to cross cancel and become a 3. Here, this is going to cross cancel and become a 2. Because remember, we're distributing it. So you should end up with what? 3g minus 2. What do you got?
What about the one where it's like, I'm going to pick one of the odds.
Go for it. Tell me which number.
1/2, 26 or 25.
All right, here's number 25. That's a great one. That one was on my list anyway. All right, here's number 25. It's a freebie. No, it's not, because it's odd. So 1/2 of 8u plus 10v minus 1/3 of 15u minus 3v. 15u minus 3v. Check me, Philip. Do I got everything written right? Okay. I throw ones underneath so that I don't screw up and do something silly. 1/2 of 8u is 4u because the 2 and the 8 reduce. 1/2 of 10v is 5v because the 2 and the 5 reduce. And 1/3 negative of that is negative 5u. 1/3 negative of 3v negative is a positive 1v. 3 goes into that 5 times, 3 goes into that 1 time. Negative, 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 negative becomes positive. Combine like terms and you should have 9u plus 6v. Wait. 4 and negative 5, that's a u. Thank you. U plus 6v. Negative 5u, positive 4u. That's why I need you guys. You guys keep me in check. Okay. Yes, go ahead, Jada.
I was gonna ask, like, if you look at the oral academic, like 11 and 12, how it says not 0.
That just says that if you have a division problem, like 1 divided by W, what they're telling you, and you're going to see that a lot throughout your career now, 1 divided by W multiplied by, state the reciprocal.
Should it be done?
W cannot equal 0. So what is the reciprocal? The reason they're telling you W cannot equal 0 is because if 0 was W, then 1 divided into 0 groups would be a magic trick. W, the denominator can never be 0. So anytime there's something in a fraction where it's a variable, they are going to tell you that that variable's, that the value of the variable can't be 0, even though it's kind of understood, because you would never assume this to be 0. Okay, so W would be the reciprocal. That's why they tell you that. Anytime there's a variable in a denominator, they'll tell you that.